the final segment of complex numbers. It's powers of I and multiplying, or in general just operations with complex numbers. So the first thing you have to know is what happens when you multiply I. What you have to remember is that I is the square root of -1. And the square root of -1, if you were to say raise it to the 0 power, like here, well, it's just like anything to the 0 power. Anything to the 0 power is 1. Now, when you raise something to the first power, well, that's just itself. So things don't start to get interesting until you start squaring it. So hopefully you remember, if I am to square a radical, they basically just cancel right out, and we're just left with -1. Because when you square the square root of -1, you get -1. And now if I cube it, well, cubing is just like taking this times this. I cubed, I guess I could write it right here. I cubed is the same as I squared times I. So it's the same as -1 times I, which is -I. So these are your 4 powers of I. And truthfully, that's all you have. There's 4 powers of I. Because once you get to I to the 4th, let's just go with that. I to the 4th right here is I squared times I squared. Well, what is I squared times I squared? -1 times -1, which is a +1. Now you could continue going through this, but I just came right back to this answer right here. The next answer is I, because we just basically take 1 and we multiply it. It's 1 here, and we multiply it by I. I to the 4th times I is just I, and then this just pattern keeps going. So then it's -1, -I. So these are the 4 powers of I. 1, I, -1, -I. And you just, this is the pattern. 1, I, -1, -I. 1, I, -1, -I. So you can think of it as a circle, and you kind of, every time you do a different power, this would be I to the 0, I to the 1st, I to the 2nd, I to the 3rd, and I to the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, etc. So if I say find I to the 34th, you're going to have to go around this a few times. But if you think about it, you only have to do it for where it isn't divisible by 4. So there's only 4 possible answers. So if I take 34 and I divide it by 4, that tells me how many times I went around the circle. So how many times am I going around the circle? Well, 4 into 34, well, that's 8 times. So divide that. Well, I had 2 more to go. I went around 8 times, but then I had to go 2 more. So this is the same as I squared, which is -1. So I to the 34th power is -1. So let's just try it a couple more. Let's try this one with you. Maybe you can try the other ones. Well, 28. So if I take 28, well, how many groups of 4 are there in 28? Try 7. Oh, look at that. It goes perfectly. That means you went around the circle exactly 7 times. So the exponent is the same as the exponent as I to the 0. So it's just 1. So how about 302? 302. Divide that by 4. 7. 28. Bring down the 2. So 5. So 4 goes into 302 75 times. If you don't know how to long divide, you're gonna have to talk about that with me tomorrow. Okay, you went around the circle. You went around that circle up here 75 times. and then you had to go another 2 more, just like 34. And then 115 divided by 4, so that goes in twice, 8, another 7. Well, it goes around 27 times with 3 left over. So I to the 115th is the same as I to the third, or negative I. So when you're finished, I should never, ever, 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 ever have an exponent. Okay? Because if you did, it's not fully simplified. So here now it's just math. So you just do the math for all of these problems and then reduce so that you don't have an exponent on your I. That's it. So you deal with all of these problems as if that I is simply a variable. So remember, do the exponent first. So 2 to the third is 8. I squared is I to the 6th. Remember? Power to power you multiply. So it's 3, 2 to the third power, I to the 6th power, 2 to the third is 8, and so on. Now let's distribute in. 8 times 3. This isn't really just, whatever, it's just multiplying. 3 times 8 is 24, I to the 6th. And what is I to the 6th? Well, that's the same as I squared. Or you can just look on the page before. And so it would be 24 times negative 1, which is negative 24. Okay, so remember this I to the 6th. You take 6, divide it by 4. How many times does 4 go into it? Goes in once, with 2 left over. So it's the same as I squared. Remember, I squared is negative 1. So that's where this negative 1 right here came from. So since it's 24 times I to the 6th, it's 24 times negative 1, which is negative 24. Distribute here. I times, just distribute. 5I minus 2I squared. Well, there's nothing that can happen here. I doesn't have an exponent. But here, remember, I squared is negative 1. So it's negative 2 times negative 1. So then 5I, so this is negative 2 times negative 1, which is a positive 2. Okay, if you need to leave that in A plus BI form, that means the 2 has to come first and the 5I comes second. Woe is me. Multiply 2 minus 7I times its conjugate. Well, 2 minus 7I is that. Its conjugate, remember? Just change the middle sign. Exactly the same. It's just like when you're factoring dots. And then you multiply. So we can do our little box here, or whatever you desire. So this is negative 14I, this is positive 14I, and then this is negative 49I squared. So these two cancel out, and we're left with 4. And then this here is negative 40, that's a mess, but it's negative 49I squared. So remember, I squared is negative 1. So this becomes a 4 plus 49, because these two, negative 49 times negative 1 is positive 49, so that's a 53. In the end, 53. So when you multiply anything by its conjugate, you lose the I. You lose your I. Okay? And we'll verify that that is a solution. Or let's just say plug it in. It may not be a solution. I may have messed this up. But anyway, let's just, what we do is we take this thing and we plug it in. Negative 1 plus 2I squared plus 2 times negative 1 plus 2I plus 5. We want to see if that equals 0. So it's like a check. So we multiply, we square here. So let's just take this over to the side. Negative 1, 2I. Negative 1, 2I. So this is positive 1, 2I, negative 2I, negative 2I, and then 4I squared. So remember, what all that this does is if you have a negative an I squared, it simply changes this from a positive 4 to a negative 4. That's all it really does. So this is, now that this is a positive 1 and a negative 4, because we simplified that, these two combined is a negative 3. And these two combined is a negative 4i. Right? You may want to do that a little bit more involved than I just did here, because that's a little messy, but do what you got to do. So then we take this 2 and we distribute it through. So it is a negative 2. So take this positive 2, distribute it to here also, and that is a positive 4i plus 5. Combine our like terms. This goes away. This goes away, and this is negative 3, negative 2, and a positive 5. Well, that's 0, because it's negative 5 plus 5. 0 equals 0. Check. Done.